A geometric series is a sum of the terms of the geometric sequence. The symbol, this is called a summation symbol. So the summation symbol is used to represent the sum of a series. So the sum of a geometric series is the sum m equals 1 to n, a sub 1 times r to the m minus 1, which this is just the same as s of n, which is, if you could make this change, this should be a sub 1 times 1 minus r to the n divided by 1 minus r, where r is not equal to 1, because otherwise you get 0 in the denominator. So summation notation gives the expanded form of a series. So this is summation notation. So you basically adding each term in your series. So let's look at an example of this. It says, consider the series the sum of n equals 1 to 7 of 3 times 2/3 to the n minus 1. It says, write the expanded form of the series out. So the expanded form of this would be the summation n equals 1 to 7 of 3 times 2/3 to the n minus 1. So since it says n equals 1 to 7, I'm going to start with n equals 1 and go all the way up to n equals 7. So, and I'm going to be adding each of these terms together. So summation means you're adding everything up. So in this example, 3 times 2/3, we'll start with 1 to the 1 minus 1, plus 3 times 2/3 to the 2 minus 1, plus 3 times 2/3 to the 3 minus 1, plus 3 times 2/3 to the 4 minus 1, plus 3 times 2/3 to the 5 minus 1, plus 3 times 2/3 to the 6 minus 1, and then plus 3 times 2/3 to the 7 minus 1. So this is what this expanded form of the series would be. And if you were to actually work these out, this would be 3 times 3 to the, or 3 times 2/3 to the 0, which this would just be 3. If we were to simplify this one, this would be 3 times 2/3 to the first power, which would just be 2. This next one would be 3 times 2/3 to the second power, which would give you 4/3. The next would give you 8/9. And then the next one would give you 16/27. And the next one would be 32/81. And the last one would be 64/243. So this would be the expanded form of the series. And you could add all those up and see what that sum would be. But there's an easier way to compute the sum. So to compute the sum, so this is the expanded form. To compute the sum, you state what the first term of the sequence is. And the first term of the sequence would be, if we're using the summation notation, it would be this term. So this is your first term. So it is 3. Your common ratio is a value in the parentheses. So your common ratio is the 2/3. So your common ratio is 2/3. And n, so we went all the way from 1 to 7. So n is 7. So to find the sum, we're going to go back up here. We're going to use this formula right here to find the sum. So we're going to use S sub n equals a sub 1 times 1 minus r to the n over 1 minus r. So we'll plug in our values. A sub 1, we know that's 3, times 1 minus, our common ratio is 2/3, so parentheses 2/3, our n is 7. Divided by 1 minus our common ratio, which is 1 minus 2/3. So if you put this into a calculator, which would be probably the suggestion here, you would get 2059 over 243. So that would be the sum of this series. So if you were to take and add every single one of these terms up, you would get 2059 over 243. So if you have any questions on the summation or so geometric series or anything about geometric sequences, please write them down and bring them with you to class. And that does it for this section.